Okay, so for this part of the lesson, I'm going to talk you through exponential graphs and how you draw them. So I just want to give you a little bit of background on what exponential growth is. And the most common example you'll see, which often comes up in science, is how bacteria grows. In real life at the moment, I think most people will have associated exponential growth with coronavirus and how you can see the spread of that and what happens when things are growing at an exponential rate. So if we just think about this criteria at the moment, so if we have a bacteria which is known to double in quantity every hour, a sample is being prepared containing 500 bacteria, and we want to know how much there'll be in the same time tomorrow, so 24 hours later. We think about it, at the start of time, there are just the 500 bacteria. In 1 hour's time, it's doubled, so we'd end up then with 1,000. In 2 hours' time, that will double to give us 2,000, and then so on for 3 hours. And you can see the pattern. There's a quicker way, though, of working that out. So hopefully you can spot the fact that you can simplify the times by 2 bit to 2 to the power of how many 2's there are. And therefore, thinking about how you would calculate the number of bacteria in 24 hours' time, that's going to be 500 times 2 times 2 times 2, 24 times, and therefore can be better written as 500 times 2 to the power of 24, which is going to be a massive number. So you can see when something just doubles, okay, so at a rate of doubling, it's going to be a massive impact on that one. Okay, so actually when you come to draw exponential graphs, you will see that they start off reasonably low, but they shoot up to sort of massive numbers or infinity very, very quickly. Okay, so we're going to have a look at how you can draw that for a graph. So we will always see exponential equations as y equals a number to the power of x. So when you're using your calculator, you will need to put in 3 to the power of the x value. Okay, so we're going to go through how you would calculate them and what your outcome is, and then also how you would draw it. You will see in the Google Classroom that the first question for the set of questions that I've asked you to do is this question, y equals 3 to the power of x. So you may find that printing that sheet out or drawing out that table and that grid will help you to do this question. Right, have a think about how you would calculate this one and then hit play when you're ready for me to go through it with you. Right then, first of all, in your calculator, you want to put in the x value of -3. So it's going to be 3 to the power of -3. Those of you that are good with your indices will remember that the negative power means I put a 1 on top and 3 cubed on the bottom, which will then simplify to 1 over 27. But if you were to pop it in your calculator and round it appropriately, it will come out at 0.04. We do the same then with x equals -2. So I'm going to get 3 to the power of -2. That's going to give me a 0.1 recurring, so to 2 decimal places, because remember, you can't plot these particularly accurately. You've just got to do the best you can with these tiny numbers. That's going to be 0.11. And you'll see on the graph, it's starting to plot those points as we go through them. So next one is x equals -1. So 3 to the power of -1. That's going to give us a third, or 0.3 recurring, so to 2 decimal places, 0.33. And you can see the graph is just starting extremely low. It's just starting to rise a little bit. When we get to 0, hopefully you can remember what anything to the power of 0 is, in which case it is always 1. Okay, and therefore the graph's gone up just a little bit more. Then 3 to the power of 1, so remember anything to the power of 1 is just itself. So that becomes 3. And then we get 3 to the power of 2, so 3 squared gives us 9, and 3 cubed then will give us 27. So as I say, with an exponential graph, it starts off very low, but it will then shoot up to big numbers very, very quickly. So expect to see the graphs looking like that, or a mirror image of if it is a negative graph. So you've got a set of questions to have a go at. Make sure you're identifying which ones I want you to do first and which ones I want you to do as an extra challenge if you have time. Any questions or problems, let me know. Remember, always draw graphs with a pencil, please. If you're able to print them, brilliant, but if not, make sure you're drawing your axes out exactly as they are in the question so that you can plot them accurately. Okay, let me know if you need help with anything.